Hello, this is Jenny from Medsun Power. Recently, our customers consulted us a technical question. He has purchased a 48-volt 100 Ah battery with 100 amp BMS, believing it could power inverter rated below 5 kW. However, they encountered issues with that, the inverter failing to start. Upon investigation, we found that the failure to start may be due to the impact of large current, and the root cause is that there is the absence of pre-charge circuits or battery assembly BMS. So today, we are delving into the pre-charge circuit role and significance in battery system, shedding light on its importance for smooth and reliable operations. To better understand functions of pre-charge circuits, let's have a brief introduction of what is pre-charge function and how it works. The pre-charge function is a safety feature integrated into the battery management system of lithium-ion batteries, can effectively prevent and avoid the damage to circuit systems caused by inrush current. In order to achieve pre-charge, we use a very simple and effective method, placing a small resistor in parallel with the relay contacts before closing the main relay, just like this diagram. Its working principle is like this. First, when the battery BMS activates the battery power, it initiates the closure of pre-charge relay and offers a small current to charge the load. Second, as the voltage across the capacitor reaches 95% of the bus voltage, the main relay is closed, enabling the whole system to operate at full power. Finally, the pre-charge relay is closed. So in real life, in a solar system, what are the advantages of using pre-charge circuit for the inverter? We know that the input current of the inverter is inverter power divided by input voltage. For example, if there is a 48-volt DC 10 kW inverter, then the input current that the inverter can withstand is 10 kW divided by 48-volt DC equal to 200 amp. When first connecting a battery to a load with capacitive input, there is an inrush current as the load capacitance is charged up to the battery voltage. With large batteries which have low source resistance and powerful load which have large capacitors across the input, the inrush current can easily peak 1000 amp. Such a large inrush current is much greater than the current during stable operation and current that the inverter can withstand, which will cause the inverter to be damaged by the battery. The pre-charge circuit can supply power to the inverter with a small current when battery and inverter are connected together, and until the batteries supply the inverter with a relatively stable and low current. With pre-charge function of battery BMS, it allows safe use of a wider range of inverter with different input requirements, helping to protect the inverter and other connected components from premature wear. This extends the life of equipment and can reduce their maintenance cost. Besides, the pre-charge function can also avoid the following issues. First, the main fuse will blow if asked to carry the inrush current. Second, the contactors, if present, will be damaged by the inrush current. Third, the battery cells are not rated for the inrush current. However, incorporating a pre-charge circuit into a BMS design comes an additional cost. In order to save cost, many batteries on the market do not have a pre-charge function. While Medsun stands out in the battery market by offering a selected range of rack-mounted and wall-mounted models that incorporate a pre-charge circuit feature, we add these functions in order to enhance user experience, product design professionalism, and improve the usage flexibility and safety. In conclusion, the pre-charge function within the realm of lithium battery technology represent a significant stride toward enhanced intelligence and safety in various applications. As the adoption of lithium battery continues to grow in our daily lives, it becomes increasingly crucial to recognize the pivotal role played by this safety feature. Its presence is not just a feature, but a necessity, offering peace of mind and reliability in our increasingly battery-powered lives. About is all I would like to share with you today. Thank you for your listening. See you next time. Bye.